Hi everyone. So I think I'll start. Just let me know if you can hear my voice, and then I'll start the session because there's no point waiting for 5 more minutes. I thought it would take me 5 more minutes to get ready, but I think we can get started now. Okay, so I got a comment which says that you guys can hear me. So let's start. Today's session will mostly do questions. We won't do a lot of theory or anything. And we'll try and see whenever you get a question. The main objective is to expose you to different kinds of questions. We have been exposed through a lot of them, but these will be certain different kind, as in they don't follow a very set pattern in many cases. So that would be an exercise. Plus the standard would be slightly higher. So let's go ahead and get started and see how it goes. So this is the first question which we are going to do. The question here is, how many real roots are there for the equation? So an equation has been given to us, which is x minus 3 into x minus 5 into x minus 7 plus mod of k into x minus 4, x minus 6, x minus 8 equal to 0, where k is a real number. And now we have to say how many real roots will this equation have. Now, it's not a very easy question because there is no direct way to do it. If you start expanding the brackets and then trying to solve, it will take a lot of time, and even then you might not be able to solve. So there is a way to do this, and let's see the way, and then we'll see what we can learn from that particular method. So one thing which you should notice is that this will be a cubic equation, right? So it will be a cubic equation, and a cubic equation can have maximum 3 roots. It can have 3 or less real roots. It cannot have more than 3 real roots. Now that information is important. Look at the numbers here. So they are 3, 4, 5, 6, 7, 8. So if you plot them on the number line, 3, 4, 5, 6, 7, 8. These are the numbers that we are seeing in the equation. If you look at, say, x is equal to 3, what's happening to the equation? X equal to 3. The first part of this equation, x minus 3, x minus 7, this will be equal to 0. And the second part will be mod k into 3 minus 4, which is minus 1, 3 minus 6, which is minus 3, 3 minus 8, which is minus 5. So since mod k is always going to be positive, this is going to be a negative number, right? So at x is equal to 3, this expression is negative. Let's name it fx. So at x equal to 3, fx is less than 0. What happens at x is equal to 4? So x is equal to 3, the function would have been somewhere below the number line. It would have been in a negative region. What happened at x is equal to 4? At x is equal to 4, the first expression is 4 minus 3, 1 into 4 minus 5 minus 1 into 4 minus 7 minus 3. So this is a positive expression, and the second part will be 0. So overall, the function is positive. So at x is equal to 4, the function is positive. So it's in the positive territory. Same way we check for x is equal to 5. The first part is 0 because this expression will be 0, and the second part will be positive because 5 minus 4 is 1, 5 minus 6 is minus 1, 5 minus 8 is minus 3, minus minus plus. So overall this expression will be positive. So the expression is positive at x is equal to 5. And you can continue to check at x equal to 6, it turns negative because the first part is negative, the second part is 0. At x is equal to 7, it remains negative. First part is 0, second part becomes 3 into 1 into minus 1, which is minus k. So it is negative. And at x is equal to 8, it is again positive. Now, if you remember in the last session, we had discussed that a polynomial function is continuous. That much we had discussed. So this function will be continuous. It is negative at 3, then positive at 4 and 5, then again negative at 6, negative at 7, and positive at 8. So it is going to cross the number line thrice. It is going to be 0 at 3 points between these values, between 3 and 8. and hence this equation will have three solutions, three real solutions. Now, I knew the solution, so I could explain it to you. Thinking like that in the exam might be tricky, but it's not a very obvious way to think that, and it fits for this equation. There might be a different equation, so it's not a method. It's something which you have to be very observant and observe during the exam. So this will be considered a difficult question when it comes in the exam. The purpose of doing such question right now is that now that you have been exposed, you can try thinking in this method during the exam. Now, like, think of it like you have one more weapon in your armory. You should think about it maybe just by substituting for some values which are there in the expression. Can we get something more about this expression, right? So, and that's why we do more difficult questions or different kinds of questions, just so that in case something like that comes, you should be able to think along these lines. Again, you have watched it right now. I see some people liking this solution also and all that kind of stuff. The benefit of this will only come if you like revise it once or twice at least before the exam, because right now you think you know how to solve this, you have got a new method or whatever, but if you do not revise it, you will forget within the next 2 or 3 days. Whatever we read, 50% we forget within 2 days. So you need to revise it to have enough confidence that when the question comes in the exam, you are able to do a question, because it won't be the exactly same question, right? It can't be an application, it can be something which looks similar to this. And then if you haven't revised it, it would be much more उस केस में you will be afraid, you will be frightened, because you remember you had done the question but you don't remember the solution, so suddenly you will be frightened कि क्या हो गया. So it's better that you revise it twice or thrice. I keep sounding like a broken record, but it is important. That's why even if you don't do any of these questions, it won't hurt you in the exam, but whatever you have done, you need to revise it and be very, very confident of what you know. So we'll move on to the next question. Now this is relatively simple. If such a question you should be able to solve. So the question is, there is just one thing which you need to notice, and that's why we have this question here. How many integer values of x satisfy both the following inequalities? So let's look at the first one. We did how to solve polynomial inequalities in the last session. So if you don't remember, go and revise. What we had decided there was that if a term is always going to be positive, you can ignore it. So here x plus 3 square is always going to be positive, so you can ignore it. X minus 10 cube less than 0. So you'll just plot 10 as one of the key points. It will be positive to the right of 10 and it will be negative to the left of 10. So the inequalities which solve these equations, this inequality, the values which solve it are minus infinity to 10. And since there is no equal to, we'll put but you also need to check for whatever values this expression would have been 0. So this expression would have been 0 at x equal to minus 3, and there it won't have been less than 0, it would have been equal to 0. So you need to exclude minus 3 from the solution set. So excluding minus 3, all the values from minus infinity to 10 will satisfy this particular inequality. And same way we'll need to solve for this. Here x minus 8 to the power 4 is always going to be positive, so we just need to do for minus x plus 4 to the power 5, minus x plus 4 to the power 5 less than 0, or we can multiply by minus on both sides and we'll get x plus 4 to the power 5 greater than 0. Again, you can plot the number on the line, minus 4 plus minus. So this equation will be true for all the numbers from minus 4 to infinity, so minus 4 to plus infinity, but you will check for the value for which the expression is 0, which is x is equal to 8. For x is equal to 8, the function will be 0 and not less than 0. So you'll exclude 8 from the solution set. The question is asking how many integer values of x satisfy both the following inequalities. So how many integer values? So the overlap between this and this solution. You can draw on a number line also. Ideally, you should be able to do it mentally. We'll just try and see. So here is 10, here is minus 4. So for the first inequality, the solution is minus infinity to 10. So this will be the solution, except for minus 3 where it is not, that is not included in a solution. And for the second part, it is minus 4 to infinity. So this is the part of the solution, except for 8, which is not part of the solution. So all the integers between minus 4 and 10, excluding 8 and minus 3, will be solution. So you can count those integers, remove these two, and that would be your answer. Again, this is the kind of question which can actually come in the exam. The previous one is a tough, well, I think it may probably would not come something like that. These kind of stuff will come because it just requires some keen observation, a good understanding of functions, and you should be able to solve these questions. So again, practice this. You need to be observant of what not to miss in an exam setting, and then you should be able to solve. I'll just check comments in case there are any questions. So I don't have any questions yet. If you have questions, keep commenting. If I will try and respond right now. If I don't, I'll respond later on whenever I go through them. So just give me a second. I'll just check if there is any comments, etc. Okay. So I hope this question is clear. We'll move on to the next one. Now we posted this question on the group yesterday, and nobody who responded got it right. So we have included it here, and it's not a very straightforward question. So nothing to worry about if you didn't get it right. But let's see how we can do that, because we can learn a few things from this question. So in general, if a question comes in trigonometry, it would not have a lot of trigonometric stuff in there. It would be something of this sort where the trigonometric content is fairly less. So you're just trying to cover. So here also you don't need to know a lot of trigonometry. The only thing you need to know is sine square theta plus cos square theta equal to 1, and that sine theta and cos theta will vary between 0 and 1. So that is fairly basic. Sine theta and cos theta will vary between -1 and 1. Sine square theta and cos square theta will vary between 0 and 1. So the way to do this is, if I assume sine square theta equal to t, you can assume cos square theta also, the answer would remain the same. You get 2t to the, so cos to the power, just a second. Cos 4 theta can be written as 1 minus t square. 1 minus sine square theta is cos square theta, and the square of that, plus t plus 3. And now this is a quadratic equation which we have studied well, which we have researched well, so we know how this function will behave. We'll just expand it very quickly. So 2t square minus 4t plus t minus 3t plus 2 plus 3, 5. So this is the function, and we need to find what would be the maximum, what would be the minimum value. But there is one restriction. T will only be between 0 and 1, right? Because it's sine square theta, and sine square theta cannot be more than 1. It cannot be less than 0. It can only take values between 0 and 1. So we need to see how this function will behave between 0 and 1, and then we can choose the maximum and minimum. As you would have observed by now, in such cases, my favorite approach is just quickly looking at the graph, especially if it doesn't take time. And if you have practiced them well, it shouldn't take a lot of time. 2t square minus 3t plus 5. The first coefficient is positive, so it will be an upward, it will be a graph which is pointed upwards. So it will be something of this sort. The minimum point will be at minus b by 2a. So this will be at 3 by 4 will face the minimum point, and which is between 0 and 1, by the way. So at 0, the value is 5. So at 0, the value is 5. At 1, the value is 5 plus 7 minus 3, 4. So 1, the value is 4. So 0 and 1, the value is 4. And at 3 by 4, which is the minimum point, we know it can be minus d by 4a. So you can calculate it that, or you can just substitute 3 by 4 in there. I'll do minus d by 4a. So minus b square 9 minus 4, so it's, I think, 31. So 31 by 8. So at 3 by 4, it will be 31 by 8. So the graph is of this sort. The graph is of this sort, and this is its minimum point. So you know what is happening between 0 and 1 to the function. The minimum is fairly clear. Between 0 and 1, the minimum is at 3 by 4, and the minimum value is 31 by 8. The maximum, you will have to check for both of these values. We checked right now. For 0, it is 5. For 1, it is 4. So the maximum will be 5 for t equal to 0. And hence the range becomes 31 by 8 to 5. So this is how we have solved this question. It might seem a bit tricky right now. You need to make it easy for yourself. when you do it yourself, then you refer back to the video how it was done. You will make it easy for yourself. If you have revised the previous 2 lectures, then it would seem easy right now. If you haven't, it would seem more difficult than it is. It is not difficult. Once you are got till this expression, making this curve and realizing what is the maximum and what is the minimum value is not tricky at all, and you should be able to do that in like 35-40 seconds. But for that, you'll need to revise the previous stuff and get comfortable with all that. So uh, and that's your job now going forward, to make this question easy for you, so that you can solve similar ones when they come in the future. So I'll move on to the next. I'll see if you have certain comments on this one. Again, feel free to comment. I'll try and respond. But meanwhile, I'll move on to the next one. So after a few questions, we'll take a break of 5 minutes, and you can ask if you had any questions on previous stuff, or if you have any doubts. This one is relatively simple. A, B, C, D are four positive numbers, none of which are equal. We have been given x is equal to a square plus b square plus c square plus d square by this. And then we have been asked what can be said about x. So here, this will be what we'll use. So this is greater than this, and hence these two will only be equal when these two expressions are equal. Actually, like all the values are equal, ab equal to bc equal to cd equal to da, in which case this will be equal, otherwise it will be greater. I think we'll skip this for now. We'll do it when we do am greater than gm. So in the future we are going to discuss it a lot in doing maximum minima and such stuff, how arithmetic mean greater than geometric mean can be used. So we'll cover this question at that point. I think right now we can let it be. If you want, you can try yourself. The answer here will be x greater than 1, but we'll do it at that stage. So I'll leave it for now. Now this question again is not easy. I think I have kept the more difficult ones early on. I think there were some easy ones also, but they are, I think, at the back. So here what you are given is a and b are roots of this particular equation, 2x square minus 7x minus 10, right? And a is greater than b. Then it defines Zn as a to the power n minus b to the Rn. And we have to calculate the value of 2z6 minus 10z4 by z to the power 5. So the general approach will be to look at the expression which you need to solve. So let us look at it and how we can solve. So 2z6 minus 10z4 by z to the power 5. z6 will be a to the power 6 minus b to the power 6. z4 will be a to the power 4 minus b to the power 4. And z5 will be a to the power 5 minus b to the power 5. Now what do you do? Because you know from these equations what we have done earlier, we know a plus b, a into b, all that we know. We can solve for a and b, but that would probably be complicated. If it were very easy, we won't have such a question. So how else can you simplify this? And that's where the trick is in this question. The other thing which you can do is try and rejig things. So you bring together the a terms and the b terms. So I am bringing together the a terms and the b terms, but does that help me in any way? Still not very clear. Now here what you need to observe is that if a is a solution of this particular equation, then we also know that 2a square minus 7a minus 10 is equal to 0. Right? Because a is a solution. So for this will be true. And same way 2b square minus 7b minus 10 is equal to 0. Can we use that? And now if you observe, you can sense something. If you take a to the power 4 common, what is left inside is 2a square minus 10. And you have 2a square minus 10 here. So if we take a to the power 4 common, we are left with 2a square minus 10. And then if you take b to the power 4 common, you have 2b square minus 10 by a to the power 5 minus b to the power 5. Again, 2a square minus 10 is equal to 7a, which you can use from this relation. So 7a to the power 5, this will become, because we'll substitute this expression with 7a, and same way this will substitute with 7b. So this becomes 7b to the power 5 by a to the power 5 minus b to the power 5, and this becomes 7. Again, the thinking here is not very straightforward. It's not very easy to think that we'll put in a and b in the equation and then substitute it over here and get it. But it's not very far-fetched also, because there is a concept which you can use going forward, which is if you are given roots, then you should also be very cognizant that the roots will satisfy this equation, and you can use that, and it is used in very many questions in a different way. So you should not forget that if a is a root, then 2a square minus 7a minus 10 is equal to 0, and you can use you can use these values any way you want. If you see 2a square minus 7a in some expression, you can substitute it with 10. If you see 7a plus 10 in an expression, you can substitute it with 2a square. So this is in a way, I don't want to use that word trick, but in a way a method of approaching the question also. So once, if you get stuck, and the reason why we are not able to think along these lines is because it's not very obvious to think along these lines. Very few questions, there are many questions, but compared to the entire volume of questions, very few of them use something like this. So what you should do is remind your subconscious right now, memorize this part in the subconscious, that whenever you are given roots of an equation, you also can try something like this, putting in the number in the equation and then trying to see if something comes out of there. So that's what exactly we did. We'll just very quickly look at it again. So we had the expression which we needed to evaluate. We substituted the values, and at this point it seemed very tedious to evaluate a to the power 6 minus b to the power 6, a to the power 4 minus. We can try and do that because we have a plus b, a b, and we can keep going up and try and get these values, but it would be very long, very tedious, and if it is very long, very tedious, probably that is not the right way to go. CAT exam would not assume that you will spend 10 minutes doing a question. At max, they'll assume you will spend 2 to 3 minutes solving the question. So if it seems that it is going very, very tedious, then you are probably on the wrong path. So either you find a different path or you can move ahead to a different question and come back later on. However, we did this, then we brought the a terms together, we took the common term out, and suddenly we noticed that 2a square minus 10, whatever was left inside, can be substituted by 7a, because a is a solution of the equation, and we can do that. So we substituted that, and then it was simplified very easily. So this is how you can solve this equation. Again, revise it. There is not a general pattern to these questions. This is just exposing you to all the types out there, so that when you get something in the exam, you're not caught on the wrong foot. This one is fairly easy, so I won't spend a lot of time on this. Here you are given a plus b plus c is equal to 25. You are given a plus b plus c is equal to 25, and you have to calculate 1 plus b into a plus c equal to 144, and what you know is a plus c is equal to 25 minus b. You know it from the first expression. You just substitute it in the second expression, so you get 1 plus b, 25 minus b equal to 144. And then this is a quadratic equation. You can solve a quadratic equation to get the final answer. Ideally, you can use options also to substitute it, but solving it also won't take much time. So from this stage, it should not be very difficult. So this one will be an easy question. Just put it in there because you know that it's not very difficult to, as in you don't miss such stuff, that a plus c is here, then you can use a plus c directly from here. And some people get confused that there are 3 variables or only 2 equations, to how do we solve. So in such cases, a plus c is actually one variable, because even if I added a d here, a plus b plus c plus d, and I put a plus c plus d, still it's acting as one variable, because a plus c plus d is coming together and you have been asked to find b, not one of those. So just keeping an eye out for that kind of stuff. We'll take a short break after this one because I think the content is slightly heavier today. So fx is ax plus b plus c. plus c, and it has its minimum value of 15 at x is equal to 4. So this function at x is equal to 4, it is equal to 15, and that's its minimum value. We are also given that f2 is equal to 31, and we need to find f5. And how can we solve that? Now, the one thing which you need to note to solve this question is that if the expression is like this, the minimum value of mod ax plus b will be equal to 0. And that will happen when x is equal to minus b by a, right? And c's value is not changing. So this expression's minimum value will happen when this expression, when the expression under mod function is having a minimum value. So at x is equal to minus b by a, the function will reach its minimum value, which will be equal to c. I hope I didn't lose you and you guys got what I'm trying to say. So what I'm trying to say is this. Let's look at it again. We have an expression of the form ax plus b plus c. The expression on the outside doesn't change. Plus c is constant, right? So the function minimizes when this expression minimizes. And this expression does not go below 0. The minimum it goes is to 0. So the expression minimizes when ax plus b is equal to 0. At that point, the minimum value of the expression, which is equal to c. Using this, we can solve this question. We know that it has a minimum value of 15. So c is equal to 15, right? Because the minimum value will be c. The minimum value is that x is equal to 4. So we substitute 4 in here. 4a plus b is equal to 0, or b equal to minus 4a. We are also given that f2 is equal to 31. So f2 is equal to 2a plus b plus c, and this is equal to 31. We know c is equal to 15, so we'll substitute that. We know b is equal to minus 4a, we'll substitute that, and we get minus 2a is equal to 16, or minus 2a equal to 16, or minus 2a equal to minus 16. And from here you get a equal to 8 or minus 8. And b is equal to minus 4a, or b is equal to minus 32 or 32. And then you can calculate whatever value is needed. If you ask to find f5, you can calculate f5, which is equal to 8x minus 32 plus c, which was 15. So you can substitute it here, x is equal to 5, and you'll get the answer. And I think it should not matter which one you take. You take this set of solution or you take this set of solution, it doesn't matter, because the number inside the mod function will remain the same. So you can use either, and I think you'll get only one answer. So you can calculate f5's value from here. So I'll take a quick pause here. It won't take a very long pause, 2-3 minutes. If you have some comments, if you have something to say, please let me know. We have around 10-12 more questions. So we have covered around 30-40% of the content we wanted to, some of the more difficult ones also, but we have some more difficult ones ahead as well. So I'll wait for 2-3 minutes and just see if you have any comments. Okay, due to some issue, I can't see all of your comments. I can see some people are commenting the answer. It's fine. The time to comment the answer is not right now. You will get your time. We are going to have a test on all the things that we have covered in algebra very shortly. So at that point you can comment your answers and see how well you have learned what you were expected to. Before giving that test, please revise all this and the material that is on the portal and everything. I do not see any comments. So even if I am waiting, I don't think any. It would benefit a lot. So I'll probably continue. So the question that you have on your screen right now, I think it's a useless question. I think they would never ask such a thing. They might, but the odds are fairly low. The only reason why this question is included here is because if I do not put it in here, you would go to some other coaching institute. They will use this question. And then you will come back and tell me that they are teaching much more funkier stuff and I am teaching like basic quadratic equation all the time. So I included it just to satisfy the itch that some students have, that we need to have as difficult questions as possible. So we'll look at it, but if you don't understand it, don't worry about it. My sense is they would never ask such a question because it requires knowledge of one particular trick. Generally, CAT would not favor questions which require knowledge of one particular trick. They will ask you questions which are more fundamental in nature. But let's see. So you have to minimize this expression, and this expression can go even longer. Doesn't matter. The way to solve this is this, and we look at the way the solution is derived, and then you can even learn the solution itself. So the way it is derived is mod x minus 1. You can also consider it as the distance from point 1 on the number line. What I mean is this: if x is equal to minus 3, the distance from 1 is 4, right? Which will be the answer? Minus 3 minus 1, which is equal to 4. Same way, if x is equal to, say, 4 here, its distance from 1 is equal to 3. And that would be value of mod x minus 1. If you put x is equal to 4, the distance will be 3. So in a way, the expression mod x minus 1 is the distance that x has from point 1. So what will happen to that expression's value as I keep going closer to 1? As I keep going closer to 1, this expression's value, which is the distance from point 1, will continue to decrease, right? As I keep going closer to 1, that value goes down. As I go away from 1, so if I am moving towards this, right? So if earlier x was equal to 4 and now I have moved it to x is equal to 5, the distance has increased. So the value of mod x minus 1 will go up if I move away from 1. And same way, for mod x minus 2, you can see it as distance from point 2. If I'm moving towards 2, the value of x minus 2 will be decreasing. If I'm moving away from 2, the value will be increasing. And it's true for all these expressions. Now let's start moving on this number line. Let's say I am somewhere here, minus 5, or somewhere to the left of all these numbers. So we have 1 to 17 in there. We are at minus 5. Now we move towards this. We move towards minus 4. The distance has decreased for all these points, right? From 1 to 17, for all the points, this distance has gone down, which means the value of the function will have decreased. As I move from minus 5 to minus 4, the value decreases because all these expressions go down. If I move from minus 4 to minus 3, again, distance has decreased to all these points. All these expressions are decreasing in value. The function is going lower. I cross 1 and now I am moving between 1 to 2. What will happen? Mod x minus 1 will start increasing. All the other 16 expressions are still decreasing because now I am going away from 1. So this expression's value, which would have turned 0 when I was at 1, is now going up. But still, one expression is increasing, 16 are decreasing. I do not need to worry. The expression overall is definitely decreasing. I cross 2 and now move towards 3. If x is equal to 2.5 or 2.7, mod x minus 1 and mod x minus 2 have started going up because I'm moving away from 1 and moving away from 2. The distance of both is increasing, while the other 15 expressions are still decreasing because I'm moving towards them. At what point does it start getting balanced? The moment I have crossed 8 points, now I have reached somewhere between 8 and 9. Now 8 expressions value have started increasing. So x minus 1 to x minus 8, all these values are increasing now. So the function might start increasing. It was decreasing till here, but now it might start increasing. But there are still 9 points ahead of me whose value is decreasing. At x is equal to 9, when I reach x is equal to 9, as soon as I move away from x is equal to 9 to more right, 9 expressions value will increase, 8 will decrease, the function overall will increase. So my minimum value will come at x is equal to 9. So my minimum will come at x is equal to 9. So you can substitute x is equal to 9 in that expression and get the minimum value. So we had 17 points. At the midpoint, we found the minimum. Now what people will do is even learn it as a result. My personal thing is the question is never going to come, so learning the result is never going to help. But if you want, you can learn the result also. And it will be at the midpoint. You can also check what will happen if in place of x minus 17, we had x minus 16, as in 16 terms and not 17 terms. In which case, the midpoint will be at somewhere around 8.5, as in it will be between the middle two segments. But you should think about that yourself. But think over the explanation. I think most of you, if you understand how mod function works, will be able to figure it out once I've explained it right now. If you think through it, you will know why the midpoint, what happens and how it happens. And even if a question by chance comes, you should be able to solve it. And if you don't get it, let me know separately also, and I'll again try and explain. This is a relatively easy question. I've just put it in because we haven't covered inequalities for its mod function anywhere in our session. So I just thought I'll demonstrate a bit through this one. So 2x minus 5 less than equal to 9. So we can break it down out by 2x minus 5 is less than 9 or greater than minus 9. And that means x is between minus 9 plus 5, minus 4 by 2 minus 2 and 7. So x will be between minus 2 and minus 7. Same way 4y minus 7 is less than equal to 21, which can be broken out into 4y minus 7 less than 21 or greater than minus 21. And then y will be between minus 21 plus 7 minus 14 by 4 minus 3.5 and 28 by 4 7. So x is between minus 2 and 7, y is between minus 3.5 and 7. You need to find the value of mod x minus mod y. So you need to maximize mod x. So you need to maximize this function, and maximum value that mod x can take is 7. So this will be 7, and you need to minimize mod y. And to minimize mod y, you can take 0 as well, because 0 is within this range. So this value will be 0. So the maximum value of 7 minus 0 will be equal to 7. Reasonably straightforward. I just did it just so that we cover how to split inequalities using mod function as well. This one I won't solve today. You can do it yourself if you need to. It's a simple equation. You just need to make ranges and then check in each range. So this one's value changes at x is equal to 4. This one's value changes at x equal to 0. This one's value changes at x is equal to 3. So just make those ranges. What will be the expression like for x less than 0? What will it be for x between 0 and 3? What will x be between 3 and 4? And then what will x be for greater than 4? And include 0 on one side, whichever side you prefer, and just break these expressions in these ranges, solve, and then you should get whatever values you get. You need to check that they lie in this range. For example, for x less than 0, the expression would be x minus 4 would be 4 minus x would be minus x, and x minus 3 would be minus x minus 3. So if you solve this equation, I'll just solve the first one and then leave it the rest for you to do. If you solve this one, this becomes x is equal to minus 1, I think, if I didn't make a mistake. So you get x equal to minus 1, which is in this particular range. So this becomes an acceptable solution to us. If the answer would have been x is equal to plus 1, we would have rejected that solution because this equation is valid only for x less than equal to 0. So that's how you can solve for all these ranges. What is the area enclosed by the graph mod x minus 1 plus mod y minus 1 equal to 2? A lot of you have seen such questions. People who haven't seen such questions, it can get a bit intimidating on the first time. If you have seen it, it doesn't get, because there is only one question generally of this sort, as in it's the same question which gets asked every time. So let's draw mod x plus mod y equal to 2, and then we will see how we can do it. So if you split this expression out, it is x plus y equal to 2 if x greater than 0, y greater than 0. Sorry. X minus y equal to 2 if x greater than 0, y less than 0. Minus x plus y equal to 2, x less than 0, y greater than 0. And minus x minus y equal to 2, x less than 0, y less than 0. You can plot these. So these are definitely the 4 quadrants. You can plot these 4 lines and you will get a square of this sort. People who have done this stuff are able to plot even without doing all this. So 2, 2, minus 2 and minus 2, and you have these equations for the line, and then you can do whatever you need to. So if this area is required, just remember that the square is length is not 2, this is 2 root 2. So you can get the area, which is 2 root 2 square. You can be asked the area of the inscribed circle or the circumscribed circle, and you can get all those areas also, whatever is needed. Here what they have done is they have just changed the expression a bit to make you doubt yourself. The expression has been changed by x minus 1 plus y minus 1 equal to 2. If you remember the transformation, if you know mod x plus mod y equal to 2 and you need to plot mod x minus 1 and mod y minus 1 equal to 2, the only thing which you need to do is substitute x by x minus 1, which moves the graph 1 unit to the right, and substitute y by y minus 1, which moves the graph 1 unit to the top. So the dimensions of the square don't change, it's just this positioning changes. So the area would remain the same. So you don't even need to worry anything. Just plot this graph also if you have the time, just to be comfortable around those substitutions. वो भी revise हो जाएगा एक बार. But otherwise the area remains 8. Am I going too fast today? Because today I also feel I'm going a bit faster than I'm used to, because generally there is some theory and then some questions. So at least the theory part, even if you go faster, most people do not mind. In questions it might get a bit intimidating. So I'll again take 1 or 2 minute pause and then we'll go for the remaining questions. Ram, you asked for the difficult questions. It's all for you. The session is being run for you. I was happy doing the easy questions. It's fine. Part of it is deliberate. I deliberately go a bit fast because the videos are available, right? So you just need to know some of the you need to understand some of the things. You do not need to understand everything right now. This 1 hour is for you to get exposed to these questions, some of the solution, how to think about it. The other part which I also want you to do is you should be able to do this as fast as I am doing. Like I even explain, but just by looking at how I'm writing and now I'm thinking through, you should be able to think through as quickly. So So it is deliberately that I take all my sessions in this manner, that I do not go very slowly. I would never give time ki chalo now solve this question and then you will spend 3 minutes solving the question and then I'll come and give you the solution, because that's not the purpose of this session. The purpose of this session is to get input in a very quick, rapid manner, and then you can process all that information in your own time whenever you want, plus to get exposed to what is the kind of speed needed. For example, we have 20 questions. You should be able to do all these 20 questions in 1 hour, and we will put the same questions up as a test on our portal, the exact same questions, and you should come back within after a month or so and try and attempt those questions, all those 20 questions, and do them within 1 hour or 50 minutes, because you've already seen the solution and everything. So you should be able to do it in 45 minutes. That's how you build up speed, because by doing things which you have done it previously but repeating it over and over again, you get faster at it. So there is some of it is fast by design, but I do not want to be so fast that you're not even able to listen, or even before the image renders I have changed the page. That fast, that much is not needed. But what is needed is to emphasize the importance of speed, not only knowing, but speed is extremely important in the exam. So this question, what is the range of fx equal to sin x plus cos x? People who know the trick know how to solve it. People who don't know the trick will not be able to solve it. Ram is saying plus minus square root 2. He missed that there is a modulus function, so it can never get a negative value. So you should not make those kind of mistakes. The trick here is this. For sin x plus cos x, when you see such an expression, try this thing. When you square it, you get sin square x plus cos square x plus 2 sin x cos x. This is an identity. Sin square x plus cos square x is always 1. 2 sin x cos x is sin 2x. So just by squaring it, you get expression 1 plus sin 2x. The second expression is better than the first expression because the second expression is better than the first expression because here you know the maximum and minimum of sin 2x. There is only one function which varies, not both of them. In sin x plus cos x, both sin x and cos x vary, so it gets a bit trickier. So this one becomes easier to manage. So what is the range of fx equal to mod sin x plus cos x? You know the range of the square of this function. And it's okay to get square in this case because the function is positive. So it's very important that you know in which cases you can square and solve and in which cases you cannot square and solve. If this were fx equal to sin x plus cos x, before solving we would have had to think a bit. What is the maximum and minimum? Here it's modulus, it's a slightly easier. The squared function is 1 plus sin 2x. The maximum value that the squared function can take is 1 plus sin 2x can maximum be 1. So 1 plus 1 equal to 2 will be the max. And the minimum it can is minus 1. So 1 minus 1 equal to 0, which is the min. And since the square root will be root 2, which will be the max for mod sin x plus cos x. And minus root 2, 0 will be the min. And if we didn't have the mod function, then your minimum would have gone to minus root 2, because in that case the function can go negative also, but here since you have the modulus function, it can only stay positive. So that's what the range would be, and both sides will be included, so 0 and root 2 both included. This is what the maximum and minimum of this function will be. Again, there's something which once you know, you can do it. If you don't know, you cannot do it. So also be wary of the brackets you use. I noticed some people are commenting using the other brackets. You need square brackets. 0 and root 2 both functions can be both functions are included. Both numbers are included in the solution. So that you should be aware of. This one is relatively simple. less than x cube plus x square. So you just have to solve the inequality. I'm again doing it just so that you guys are comfortable with how solving polynomial inequalities and you don't have much doubt. We bring that to the other side. We take stuff common. So if you take x square common, you are left with x square minus 1. I am taking common from this and this. And then you take minus x common, and again you are left with x square minus 1 between the remaining values. So x square minus 1, x square minus x less than 0. And then you can take x. So what it looks like is it's x minus 1 and x minus 1 from here. So x minus 1 square, x plus 1 less than 0. X minus 1 square is again always positive, so you don't need to consider it. That leaves us with x plus 1 less than 0. So you just plot it on the number line. Minus 1, 0, plus, minus, plus. So less than 0 will be minus 1 to 0, both sides included. Just check for x is equal to 1 also. For 1 it will be 0, but it's not part of our solution, so we don't need to worry about it. So the answer will be minus 1 to 0. Reasonably straightforward. If you find this question difficult or confusing, you need to revise how to solve polynomial inequality. This should be something which you should be able to solve very quickly, very easily. It doesn't require a lot of new thinking. It just requires manipulation of expression, and you know straight away how you are going to solve this. So, Shiv is asking, is it not easier using graphs? I am not sure how you'll draw the graphs. X to the power 4, how you will try and solve the graphs. It might be, but even this way, it's not very difficult. I think it's pretty straightforward this way. Graphs, right, you might get a bit more tied up. Let me know how you have done it using graphs and I'll have a look at it. But my sense is this is better done this way. This question is a good one. I liked this question. So let's have a look. It says the below inequality is true only if x is less than minus 2 or x is greater than minus 1. What is a plus b? How will we do this? What do we know about the function which is in the numerator? X square minus x plus 3. A greater than 0, function moving graph would have been upwards, but d of this function is minus 1 square minus 12 less than 0. So d is less than 0. D less than 0 and a greater than 0 means this function will be always positive. Again, if you do not know why this is the case, you need to revise the previous class. We discussed quadratic a lot in the previous class. We discussed when you know which function is always positive, always negative, when it crosses the axis. So a reason why some people might be finding this very fast is because they're not as comfortable with what we have discussed in the past. And that's why I keep emphasizing that when you see something in this session, you need to spend, like if I have taken a 1 hour session, you need to spend 2-3 hours revising that 1 hour, especially if it is new stuff. So the expression at the top is always positive, which means the sign changes only based on the expression at the bottom. The top expression will always be positive for all values. So what we need is ax square plus bx plus 2 to be greater than 0 for x less than minus 2 or x greater than minus 1. It's a quadratic expression. Basically, it should have a graph of this sort. Minus 2 and minus 1. It should be positive for x less than minus 2 or x greater than minus 1. Right? And what would be such a graph be? Simple. X plus 2 into x plus 1 will have this kind of a graph, which will intersect 0 at minus 2 and minus 1, and it will be upward looking. So x plus 2 into x plus 1 can be x square, but you multiply it with any constant and it still remains the same function. So that you need to check. So when you do this, you get a graph expression x square plus 3x plus 2. And ax square plus bx plus 2 is the function we are trying to map. So since 2 is same as here, we know that k is equal to 1. Otherwise, if this had been 4, we knew k is equal to 2. And so a is equal to 1 and b is equal to 3. I'll wait here and I'll go through it again. Just spend a couple of minutes looking at this, 30 seconds, 1 minute looking at this, how we did it. And then I'll re-explain this particular question. I think it's a good one. I think it's an important one also because it covers a few concepts. So I'll just wait here for a bit. So this is what we did. We had said that the below inequality is only true for x less than minus 2 and x greater than minus 1. What we observed then is that the numerator is always positive. This numerator is always positive. So the sign change has to happen from the bottom expression. The bottom expression is a quadratic expression which has to be positive for x less than minus 2 and x greater than minus 1. So the bottom expression has to have a graph of this sort, with minus 2 and minus 1 being the points at which it crosses the axis. That led us to the equation that it must have x plus 2 and x plus 1 as the roots, right? But it can be multiplied with a constant and it will still have the same roots. What we were given the bottom expression as was ax square plus bx plus 2. And when we multiplied this, we saw that the constant term here was also 2, from which we realized that k must be equal to 1. If the bottom expression, for example, let's just change it a bit, had been ax square plus bx plus 4, then it would have been trickier. Because then this expression becomes x square plus 3x plus 2. So now we notice that the constant here is 2k and the provided constant to us is 4. So k is equal to 2, in which case a would have been equal to 2 and b would have been equal to 2 into 3 equal to 6. And the expression would have been 2x square plus 6x plus 4. In that case, a plus b would have been equal to 8. So that's why you need to be cognizant that if 2 and 1 are the solution, the equation need not only be x plus 2 into x plus 1, it can be k into x plus 2 into x plus 1, where k can be any constant. You multiply an equation by a number, the solution don't change. So that was something which also you need to be careful of. In this question, even if you hadn't been, you would have got the right answer, but in other cases you may not. This one is again of the sort which once you have seen it, you know how to do it. If you haven't seen it, you would not be able to do it. I think a lot of you have seen it earlier, so you should know how to solve these kind of questions. What happens in such questions is generally there is one expression which repeats itself. So this is going to go till infinity, right? But if you look at it, if we exclude this part, what remains, if we exclude this part which remains is still the same expression s, because it will again keep going till infinity. So what you can do is you can substitute the repeating part with s. So you can write this as s is equal to 1 by 6 plus 1 by 2 plus s. And then you can solve for it and it will become a quadratic equation which you can very easily solve. If you just simplify on the right hand side, this becomes 12 plus 2s, 13 plus 2s. And this is s. And then you can multiply and simplify and you'll get whatever the answer is. It becomes a quadratic equation and you can solve for it. There are various questions of this sort. This one again is a very similar question thing. You can see that some part is repeating. So if you look at this part, it is a repetition of whatever the expression you started with. So you started with t is equal to something, but then you have 4 cube, you have 4 1 by 3, and then the expression repeats post that. So you can replace that with again t. And now you can solve. So you square both sides, you are left with t square equal to 4 cube, 4 1 by 3t, and then you square again, and you're left with t to the power 4 equal to 4 to the power 6 into 4 1 by 3t. And so you are left with t cube equal to 4 to the power 6 plus 1 by 3, or t is equal to, this is 19 by 3, and you take a root 19 by 9. And then you can see which answers matter. I think here there is another thing which has been given in the option, that the answers are in terms of 16. So you will need to put 16 here, then it becomes 16 9 by 18, because you have to multiply and divide by 2. So this will be the answer. So generally such questions, if you haven't seen them before, you might be finding it a bit trickier. If you have seen them before, you know how to do them, and it's nothing new to you. So generally whatever is the repeating function, you just replace it with that part, and then you solve the question. I have 5 or 6 more. I am wondering if I am doing a lot today. Is there still gas in the tank left, or are you guys like exhausted now? Because if you think you are exhausted, we can pick this up some other time. We have some of the questions on greatest integer and logarithm left. So if you want to continue, let me know. If you don't, we can do them some other time, or I can just send you those questions and you can do them on your own. Or we can just paste them in the group and do them like that. So one person wants to continue, which is not bad. At least, even if there's one person, I'm happy to teach. Okay, let's get through it. Greatest integer function. We have a similar question in our portal also. You have to take cube roots of all these functions, and then the greatest integer, which is the integer just lower to it, is the solution. So let's look at cube roots first. So 5 cube will be 125, 6 cubes will be 216, and 7 cube will be something greater than 300. So in this value, what will be the cube root of, say, 200? It will be 5 point something, right? And same for all the numbers till 215. It will be 5 point something. And then from 216, it will be 6. And then going forward till 299, it will be 6 point something. So whenever it's 5 point xx, when you apply the greatest integer on this, the answer will be 5. When it is 6 point xx, you apply the greatest integer, the answer will be 6. So these will be 5 plus 5, so on till 215, and then 6 plus 6 till 299. And then you can count them. So 215, like there are 16 terms which will have 5 as the answer, 16 into 5. And plus remaining 84 terms have 6 as the answer, so 84 into 6. And you can total this to get the answer. So the basic, this is a relatively easier question. You should just know how to apply cube roots. and how the greatest integer function works, basically. So I do not think it should be very troublesome. This one has a concept which you should know. So, and I discussed this in the last session also for those who attended. We discussed that a number can always be written as integer plus fractional part, right? We had discussed this. So this is the greatest integer function. This is the fractional part of x, and number can be written as like that. For example, if it is 2.3, we can write it as greatest integer plus fractional part. And greatest integer will be equal to 2, fractional part will be equal to 0.3, right? So this is what you need to do to solve these questions, and some of you might have solved them earlier, so you won't find anything new in here. But you can write x as, and this helps. Generally, you substitute x by this in such questions, and then you bring the fractional parts on one side and the greatest integer part on the other side. So here you will bring fractional part on this side. So 7 into fractional part is equal to 3 into greatest integer part of x. So this is the same equation. Now how does this help us? This helps us because the right hand side here would only be an integer, and the left hand side will have to be positive. We discussed last time, fractional part of x cannot be negative. This has to be positive. So let's start with positive numbers. Can this side be integer? Yes. This side will be, can this side be 0? This side will be 0 when you put x is equal to 0. Okay, so 0, if we put that, fractional part of x will be equal to 3 into 0 by 7 equal to 0, right? And x, I just need some more space here. X, which is equal to this, will be equal to 0 plus 0 equal to 0. This satisfies all the requirements, which is fine. Then if we put greatest integer of x is equal to 1, then this side becomes 3 into 1. And then we need to solve for fractional part of x, which is 3 into 1 by 7, or equal to 3 by 7. So mod x equal to 1, fractional part 3 by 7. So you do 1 plus 3 by 7 equal to 10 by 7. And then you can put mod greatest integer of function equal to 2. You put greatest integer equal to 2. The expression becomes 3 into 2 equal to 6. Fractional part will become 6 by 7. And the number becomes 2 plus 6 by 7, or 20 by 7. And you substitute the next time when you put greatest integer of x is equal to 3. What happens is fractional part becomes 9 by 7. And that is not allowed, because fractional part has to be between 0 and 1. It has to be a fraction. It cannot be greater than 1. It can be 0 and equal to 0 or and less than 1. So it has to be between 0 and 1, including 0. So the only three values which satisfy these conditions are 0, 10 by 7 and 20 by 7. And so we can say that the equation has three values. The equation, there are three values which satisfy this equation. Again, have a look at it, and then I'll repeat what I said just now so that you get it clearly, because some of you might have lost me in between, especially if you're looking at it the first time. So what we did here was this. We separated x into integer part and the fractional part, greatest integer part and the fractional part. From that, when substituting and making the putting the fractional part on one side, we get this expression: 7 into fractional part is equal to 3 into integer part. That is helpful because we only need those values for which fractional part is between 0 and 1. And the right hand side has to be integer, as in the greatest integer function will return an integer. So we start substituting values. We start with 0 because a fractional part cannot be negative. So we start with 0, we substitute 1, 2, and we keep on substituting till the fractional part starts going above 1, in which case we stop. So we substituted for 0, 1, and 2, and we got three values, 0, 10 by 7, and 20 by 7, which will satisfy this equation. For x equal to 3, it would not satisfy, and so we will stop at this point. So this is how you do these questions. This is a slightly complicated one. I'd let it be. I can sense some people are a bit tired, so we'll do this later on. If you want, you can attempt it. I'll post it in the group and then I'll post the solution in a group as well. So you can do it over there. This one is relatively easier to understand, so we'll do this one fairly quickly. The sum of first s terms of the following series is 0. Then what is the value of s? So what this is telling you is that if you keep adding these terms to some number, the answer will be 0. Then what is that number? How many terms do I need to add for the answer to be 0? Now, if you know look at the options, it helps, but otherwise, this expression is a to the power by b into 100 into a by b to the power 199. 200, 199, and so on, right? At some point, it will start turning negative also. There will be a term a to the power b minus 1, and then a into b minus 2, and so on. So these parts will start cancelling. For a by b to the power 1, you will have a minus 1. If I were 199, you will have a minus 199. When will the expression be 0? When the number inside is 1. Then the log is 0, right? Log a b is equal to 0 when b is equal to 1. So if you can get this expression equal to 0, equal to 1, then the log expression will be equal to 0. And when will that happen? So a by b will get cancelled by a by b to the power minus 1. A by b to the power 199 will get cancelled by a by b to the power minus 199. 8 by b to the power 200 will get cancelled by a by b to the power minus 200. And what will remain is a by b to the power 0, which is equal to 1. So that will give us answer log 1, which will be equal to 0. So if you have starting with 200, you will need to go till minus 200 for the internal part to be 1. And that means 401 terms will be needed. So you need 401 terms for this expression to be 0. Again, it's easier when you know the solution. If you see this question in the exam, it's not as straightforward. It's still something which you would consider solvable, but it's not very straightforward. So now that you've been exposed to such stuff, you should keep all these things in mind and then do a better job in the exams. I have put in two relatively easy graph related questions. You should be able to do this. I'll very quickly show you how we can go through this. How many solutions does 3 to the power minus x plus x equal to 4 have? So you can rewrite this as 3 to the power minus x equal to 4 minus x. We are rewriting this because we know this graph and we know this graph. So if you do not know, e to the power x is of this nature, e to the power minus x will be of this nature when a is greater than 0. So 3 to the power minus x will have this kind of a graph, right? And 4 minus x, which is y equal to 4 minus x, will have 4 and 4 as the intercepts. So it will have this kind of, sorry. So I haven't drawn this to scale, but even if it were this kind, it will be a straight line of this kind, and this graph the other one will continue to rise. So they will intersect once in this axis and once on the other side, because e to the power x will be rising fairly steeply and the straight line won't be rising. So they will intersect at some point on the other side. So there will be 2 points of intersection. If you needed to comment more on the solution, you can also say that one point will be for x greater than 0 and the other point will be for x less than 0. To say anything more, we will probably need to solve. What else can you say? You can probably say that the negative solution will have, I think this is more or less what you can say about this. And if any other question gets asked, you can at that point analyze the graph accordingly. I didn't draw the graphs very well, so I'll try again if I can. So this graph will be a fairly steep one. So this is your 3 to the power minus x, and 4 minus x will be something like this kind of a line, and it will intersect twice. So two solutions. Then this other question, in deep blue a part is shaded. Which graph, which expression gives you the correct uh, correct inequality for the shaded part? So it's a bit dodgy question because y square equal to x, these are not functions. For a function for one x, you should have only one y, not two y's. But still, you can try and follow this. So y square, what will be the function of y square equal to x? That's actually x equal to y square, just 90-degree turn, right? So y equal to x square, y square equal to x will be something like this. And then if you say y square equal to mod x, it will just be a reflection of what is on the right hand side to the left hand side. We have done this transformation. So y square equal to mod x will be of this kind of a graph. So we have that kind of a graph here. So the graph, the line that we have, deep dotted line, is of y square equal to mod x. You need to know whether the deep blue part is y square greater than mod x, or is it y square less than mod x. And the way to do it is just check for one point on the shaded part or the unshaded part, and that gives you the solution. So if you just check, what do we know? We can see in this particular graph that 20, 0, x equal to 20 and y equal to 0 is in the unshaded part. So which equation does it satisfy? It satisfies this one, right? It satisfies this one because 20 is greater than 0. So the unshaded part is y mod x greater than y square. So the shaded part will be y square is greater than mod x. So again, we can change the graph also. We can have x square greater than mod y and x square less than mod y, in which case it will just be a 90-degree change of this. But just exposing this also to you so that you don't get confused if something like this comes in the exam. I think I have one more question which I didn't want to do anyway. So this is another of the same variety. It's a tough question. I don't think it will come in CAT. I don't think it needs to be taught. So I'll leave it. You also, I would recommend, don't attempt it. But we'll close this session here. We have covered a lot of content. If you do not revise this content, you would forget. You would make mistakes. In fact, then it would come back to harm you more than help you. Because when the question comes in the exam, you will panic. You would remember that the question was difficult, but you would not remember the solution. So you would not be able to solve, which you might have been able to solve if you hadn't done it. So it might come back to hurt you if you don't revise. So now that you have seen this stuff, I would recommend you spend some time and ensure that you know all this stuff. Thank you very much for being patient, tolerant, attending. Let me know if you have any feedback, any comments, and we will be putting, as I mentioned earlier, a couple of tests on algebra as well, so that you can test what your knowledge is and how you have improved, whether you have improved. It will have some tough questions, so don't get very disappointed if you don't score a lot, but it will also have questions based on concepts which have been discussed on the portal or on the live session. Next week onwards, I think we are going to start number system. So thank you very much.